Hey, let's talk about wastewater disposal wells. As a reminder, every time a barrel of oil is brought up from underground, you get from 2 to 50 barrels of toxic wastewater called produced water. IxWater machines treat that produced water so it can be used for agriculture, industry, and to refill the water table. Wastewater disposal wells are an important part of our modern infrastructure. They're highly regulated and very safe. There are 5 different classes of wastewater disposal wells from 1 through 5, from municipal wastewater to hazardous waste, which by the way are now banned. The kind of disposal well we're really concerned with at 29Water are referred to as Class 2 wells. Class 2 disposal wells are used for a couple of different things, one of which is to get rid of oil and gas produced water, so you know where I'm going with this. Now there's about 144,000 of these Class 2 wells in the United States, and over 28,000 of them are dedicated to use for disposal of about 2 billion gallons of oil and gas produced water every day. Just think of what we could do with all of that water. So let's take a little zoom in here and we'll show you what the Class 2 wells do and how they're constructed. First thing you'll notice is that there's an annular that extends well beyond the water table. Now he doesn't have the water table drawn here, but he does have the word drinking water, so one would assume it's about right there. And then piping that goes down, in this case, to brine disposal on the right, or on the left, all the way down to brine injection. And again, that's because these Class 2 wells have 2 purposes. One is to get rid of wastewater. The other is to inject brine in to loosen up a tough or non-traditional oil deposit to help stimulate that oil back up to the top. So again, there's well casing that goes down extremely far to protect the surface soil and certainly the water table, and then a pipe that goes all the way down to wherever they're trying to drill to. But these are, again, very, very deep wells, and they're highly regulated by the state and the United States Environmental Protection Agency. One thing I'd like to point out in Al's illustration is that he's showing what's referred to as a non-usable aquifer. And I guess that's, a drinking water or maybe a source of drinking water aquifer that's so deep that there's no expectation it will be needed or can be accessed economically. There is a case in Wyoming right now where the Oil and Gas Commission is being asked by an oil company to allow them to dispose of oil and gas produced water into what they're referring to as a non-usable aquifer because it's so far down in the ground. Now think about that. Pressures increase as you go down. So if you can push water down into a quote-unquote non-usable aquifer, why can't you bring the water that's down there up? Obviously, every situation's different, but that is one kind of concerning, I guess, trend that certain states are looking for different ways to help the oil and gas companies get rid of their produced water. And if they just treat it, we wouldn't need any of this. Here's a view of a Class 2 well from above ground. It looks just like any other industrial facility, except you might see in the bottom right-hand corner the so-called Christmas tree. That's where the lines that lead into from the disposal area go down and pump down into the well. So what's wrong with these disposal wells? Well, as I've said, they're very important to modern infrastructure, but the 3 issues that really impact society now are the huge cost of building and operating these disposal wells, the fact that we're losing these water resources, and 3, that there can be some underground disturbances caused from injecting all that water into the ground. In terms of cost, our colleague Rick McCurdy at Chesapeake Oil says they pay about 25 cents a barrel for using their own company-owned disposal wells for their produced water. The national average runs between 50 cents a barrel and $2.50 a barrel as a fee to use the well. Now keep in mind that 29Water machines can treat most produced water for less than $1 and still have that valuable water resource. The other issue is that you've got to truck the water, and you'll see these water trucks sometimes lined up around the country in different oil and gas bearing areas. An example of the kind of underground disturbances that disposing of produced water can have is in the Arbuckle Group in northern Oklahoma and southern Kansas. This essentially is a thick formation of porous limestone and other sedimentary rocks. And when wastewater is injected into the ground, the high pressure and high volume of water creates what's called a fault slippage, what you and I feel is earthquakes. There's been a dramatic increase in earthquakes in many places from shooting all that water underground. This is a map of Class 2 wells in the eastern United States. You can see Texas, Oklahoma, Kansas, New Mexico, Colorado, and then up into the Midwest, into Ohio, Pennsylvania, Illinois, and New York. Once again, we're using a diagram created by Al Granberg with ProPublica, and also in data and materials from Rick McCurdy at Chesapeake Oil, who has written extensively about the safety and cost structure for Class II wells. We got that neat well footage from the Ohio State Department of Natural Resources and the Arbuckle diagram from folks at Caltech. We're crowdfunding on Start Engine. Look us up at startengine.com/ix-water.